Okay, so we've been talking about gene mapping a lot, and what you're going to be working on today is how to actually do gene mapping. So we're going to focus in on this example right here, this first one. So I give you 4 genes and their crossover frequency. Their crossover frequency is the same as their recombinant frequency, is the same as their map units, is the same as their centimorgans. So all of this percentage, is the space between each of these 4 genes, and we're going to work on creating a linkage map for these genes. So what I'm going to do is I'm going to do this on paper because it's hard for me to do it on the computer. So I'm going to write all of them out so that when I full screen my dot cam, I'll be able to see them still. Okay. So if we're looking at this, we have our 4 genes, right? A to C, B to C, A to D, and B to D. When I'm doing this, I find it easiest to start with my largest difference because you know that those are going to be the furthest apart. In this case, it's A and D, right? A and D are the furthest apart, so A to D, we know that this is 30. Now, at this point, we're kind of done with this. We've written it down in our map. So now we're going to move on to the other ones. Okay, so we know B and D are connected by 16%, and then B and C by 24%. That's pretty large, B and C, but I don't have either of those letters written down here yet, so I don't want to start with that because I don't know where B is yet, or C really. And then A and C are like really close together, right? Only 10%. So my next point of business is going to be looking at B and D because I have D there and it's 16%, and B is also connected to C with a large gap, and then C is connected to A with a little one. I don't know if C is going to be on this side of A or this side of A because it's so small it could be either. Realistically, these genes can go anywhere, right? So you just have to be thoughtful of where they're going. But I do know that B is close to D. So I'm going to assume that B is going to be somewhere in the middle here, 16. So about the same area as where I wrote 30 before, because 30 is pretty much in the middle. So I'm going to put B there because it's a little over halfway, right? 16 is one more than half of 30. So now I see that B is there, okay, 16. So that means that there are 14 map units between B and A, right? Because 30 minus 16 is 14. So even though we know that B and A are not connected in any way, we could still say that this is 14 because we know that that's the distance. Now, 14 is unfortunately not one of our numbers, so let's see what else we can do. Okay, so B and A are 14% away, but B and C are 24% away, and A and C are 10%. Well, that's math, you know? So if I do 10% to A and C, right, because this is 10, and I go the other way, that means that this total distance between C and B is 10 plus 14, which is 24. Okay, so now I have my 24, I have my 10, I have my 30, and I have my 16. So I've made all of them. So now if I wanted to just write this a little bit nicer, which you can, but I would also just take this as your picture. You can write C, and then you can write the map units in between. like that. So this would be the best way to write, your map, and that is how you would do this. You would just have all of your genes laid out, and you would just kind of work and keep working until you get to the point where you have all of them appropriately spaced out so that you can see where they land on the chromosome.